So in our video here, we want to continue on with our discussion of our displays of data. We talked about our different types to display numerical data and categorical data, and we want to focus on how we can describe those numerical graphs in these next few videos. So when we have this graph, we want to get a quick idea of what's going on with our results. And we're going to discuss the shape, the center, and the spread in these next few videos. So first, let's start with the shape. So when you've got your numerical displayed in a histogram or dot plot or stem plot, we can begin to see trends in what's happening with our numerical data pieces. So if we have our tails roughly the same on the left and the right, the distribution can be described as symmetric. So this distribution at the top, it's a histogram. We've got these bins, these bars. They're touching. There are no gaps here. If we trace over this, the left tail, the right tail are roughly the same length. We've got this one peak in the middle. It's the same to the left and to the right of that center. So we could say it is symmetric. Now, if one tail is noticeably longer than the other tail, then we'll say that the distribution is skewed. If your longer tail is to the left, we have a left skewed or skewed left distribution. So if we look at this histogram, my tail on the right is much shorter than the tail on the left. I have my high peak in the middle with these two bars. To the right of the peak, I've only got 2 bars in the histogram, but to the left, I've got 1, 2, 3, 4, 5, 6. So it's not symmetric. I've got way more bars to the left. This would be skewed to the left. And our graph at the bottom, this histogram, would be skewed to the right. We're a right skewed distribution. We've got this longer tail on the right compared to the left. They don't look the same. It's not symmetric, but it is right skewed here and left skewed here. Now, continuing on, there are other ways to describe shape other than just symmetric, skewed left or skewed right. We can talk about the modality that we see in our histogram or our dot plot, whatever we're displaying our numerical data with. The modality is looking at the number of peaks that we see in our graph. For example, this graph is classified as bimodal. Talking about its modality, it has 2 peaks. It heads up, then down, then back up, and then back down. So we've got a peak here and another peak here, be classified as bimodal. The graphs before on the previous page, they're classified as unimodal because they only had 1 peak. So if I just flip back and look at those quickly, here there's just 1 peak at the top, it's unimodal. 1 peak with this left skewed distribution, it's unimodal, and my symmetric distribution was also unimodal. 2 peaks is bimodal, and if you have 3 or more peaks in your display, we can describe it as multimodal. So we can describe a graph as being symmetric, skewed left, skewed right, also unimodal, bimodal, multimodal. And then there is a special case that we can see, and that is the uniform distribution. So later on, the uniform distribution will get its own chapter devoted to it. But when the distribution is roughly the same height from left to right, we'll say that we have a uniform distribution. There's not really a tail that we're seeing in the left or the right. I mean, it just drops off very swiftly on the left and drops off very swiftly on the right. It's almost like a rectangle. So it's not skewed left, it's not skewed right. It is fairly symmetric. The left and the right look the same, but it is the uniform distribution. If you happen to notice any outliers, any values that are farther away from the other data pieces, we can note that as part of our shape. And note, this is only for our numerical displays. We do not describe the shape of a bar graph. As we discussed in the previous videos, with numerical data, you have to go in order from the smallest values up to the largest values every time. But with categorical data, you can put the categories in any order that you want. There's not a set order. You could put them in alphabetical order. You could put them in order from tallest to shortest or shortest to tallest. And because you have that ability to adjust the order, that would affect the shape. You could take a data set that's categorical, and if you put it in order from tallest bar to shortest bar, so tall bar, medium bar, short bar, and then shortest bar, it looks like it might be classified as skewed to the right, but you could take that same data and you could organize it from shortest to tallest, just very rough sketches, and then it looks skewed to the left. A data set can't be skewed to the left and skewed to the right. So we do not describe the shape of a bar graph because you can place it in any order. Now, thinking about these shapes, example one, what shape do you think the following types of tests would produce? So could give you quite a few different types of tests. I could give you an extremely hard test in this class where the test questions look nothing like the examples that we've seen in the video. They're just way out in left field, like nothing you've ever seen before. That would be really hard unless you've taken statistics before. I could also give you a very easy test where maybe there's a study guide, and the study guide is the exact same thing as the test. If you've watched the videos, then you should see everything on the test. Or I could give you a fair test, which is what I hope to do. All of the big ideas for the test are covered in the notes and the videos. As long as you're following along, taking good notes, you'll have a good idea of everything on the test. And then a fourth possibility, I could give you a test with two different versions, of version A, version B. Maybe version A is the easy version, just like the study guide. Version B is the hard version, looks nothing like what we've seen before. And these would produce different shapes. An extremely hard test is most likely going to give you a distribution that's skewed, and it's going to be skewed to the right. If you think about it, with a hard test, most of my grades are going to be pretty low, in the 30s, the 40s, the 50s. And maybe a few people would get up to the 70s and 80s if they've taken statistics before, but I would expect to see, a clustering of grades down here on the low side. And then maybe a few grades in the 50s, 60s, and 70s and 80s. So this would be a skewed right distribution. And a very easy test would have the opposite shape. It would be skewed to the left. I would expect most of my grades to be in the 80s and 90s and maybe even 100s, and then maybe a few grades down in the 30s and 40s and 50s if people haven't been watching the videos, they haven't been following along with all the materials that are provided in the class. A fair test, I would hope, would be symmetric. Maybe a good solid B average in 80, 81, 82, but people making higher than that, making some A's, also people making lower than that as well. And then if I gave you a test with two versions, I would probably expect to see two peaks. I would expect a bimodal distribution. I would have some grades down in the 30s and 40s for the hard version, but maybe I would also have quite a few grades up here for those in the 90s, 100s. So it would go up, then back down, then back up. So these are possible shapes that I think these might produce. We'll stop this video here and wrap up shape, and we'll move to our center of a distribution in our next video.